Hey everyone, Mr. MathWell here. I'm doing a late night video here actually for you, and I just was just bugging me. I had to get something out for 7.1 limits of trigonometric functions here for Calculus 30. And yeah, I'm just in here a little bit late here. I'm not really dressed up here tonight, but I just want to give you a quick lesson on 7.1. Now, 7.1 talks about limits of trig functions. Now, first of all, I just want to take a look at these three trig functions here. Y equals cos of theta, or cos of x, and here's in green, right? That's your cos graph. The blue graph is the y equals sine of theta, okay? And then the red graph is y equals tan of theta here with asymptotes of pi over 2 and 2 pi over 3, etc. So when we're talking about limits of trig functions, there's really nothing fancy about this at all at its base level. So if you think about this limit right here, okay, or these two limits right here, and of course these values are on the unit circle. This is part of the unit circle, right? So at, let's say at pi over 4, just for instance, pi over 4, okay, the value right here that both sine and cos share, pi over 2 is pi over 4 is 45 degrees. They're both values are root 2 over 2 and root 2 over 2. Remember, this is cos theta is the first one, and sine theta is always the second listing here. And so they both share the same value. And so this is where these graphs come from, this unit circle. So if you're doing a limit with a trig function, it's no big deal. Like for instance, if you can plug 0 in, because you know that sine is cos and tan is cos, if you can plug 0 in, sine is continuous and sine is continuous, cos is continuous, you know that they're both continuous, so you could just go ahead and plug the value in to find the limit, right? For example, if we just look at sine, as the limit as x approaches pi over 2 is going to be 1 because it's continuous and it looks like it leads up to a y value of 1. So the limit as x approaches pi over 2 of just sine x is 1. I mean, that's easy. The limit as x approaches pi over 2 of cos, the green graph here, well, it's 0. See that? So those are easy. When you have rational functions, you start getting into a little bit of issues here. So let's just see here. If I just plug 0 in, what's sine of 0? Well, sine of 0 is 0. Divided by cos of 0. What's cos of 0? Well, that's actually 1, right? So we get 0 over 1. So that's okay, right? That's 0. No big deal. If you have a 0 in the denominator, you've got problems. But for some of these, you can just plug straight in. Here's another one over here. You see that? Here's another one over here. Limit of sine of x over 4 of x as x approaches pi over 4. Okay, well again, continuous functions here, so we could just plug things in, and as long as we're not approaching a restricted value here, you know, we could just plug it in and find out what the value is. So if you look at this, sine of pi over 4 should be a value that we can find from our unit circle up there, and 4 times pi over 4 is of course just pi. So sine of pi over 4 we said was root 2 over 2. And 4 times pi over 4 is pi. So your value is root 2 over pi. That should be the limit. Now of course you could check these out by graphing them and that sort of thing, but just for this lesson I'm just kind of go over some basics here. Now you do run into a bit of a problem when you come up with something like this, but this is a very special limit. Sine of x over x, okay, as x approaches 0. So what is that limit? Now you think, well, x is 0 here in the denominator, so we got an issue. Yeah, you do. Can we manipulate this or simplify it in any way that we can get rid of this x? Not really. You can't divide those out, right? That's bad. So if we look at the graph of this, and I'm just going to quickly go over to the graph of this. Here's a graph of sine and cos. We'll get rid of those. Here's sine of x over x. Now watch this. Kind of looks like a sine graph, doesn't it? Let's zoom out a little bit. This is not a sine graph at all, and as x approaches infinity, it seems like this line gets closer and closer to 0. Now it does pop up and down, back and forth, but it kind of snakes along there, and it just kind of gets really close and just kind of hovers right around 0 here. But what's interesting is as x approaches 0, the limit is clearly 1. Okay, and that's going to be very important for us. We're going to be able to use that fact in a lot of different, to solve a lot of different limits that otherwise would be tough to manipulate, tough to to just plug values into. So this actually is 1. Now what that means is we can have, okay, oh, whoops, I didn't erase this for you already. I kind of went over this once already. But let's take a look at, well, I'm really messing this up. This one right here, okay, forget you saw that. Okay, you're not seeing this. You're not seeing this. I won't show you this much detail probably in this little video. But if we have something like the limit as x approaches 0 of sine of 7x over sine of 4x. Now there's a real tricky one, right? But again, if you think about this, we could actually use the fact that the limit of, as x approaches 0 of sine x over x is 1. We can use that, and here's how. So if I write this over 7x, that would mean I'd have to multiply by 7x out here. If I wrote this one over 4x, all that would mean was I'd have to put a 4x in the numerator out there. Now what does that do for us? Well, it does this. I now have 7x over 4x as, this actually simplifies to, because the x's cancel out later, I'm going to show you that. And here I have sine of 7x over 7x and over sine of 4x over 4x. And of course we're taking the limit as x approaches 0. Okay? So this just comes out, and because we can divide out this x now, because it's just a monomial and x divided by x is just 1, this is now a constant. So a constant, as x approaches 0, the constant doesn't change. So watch this. This is now 7 over 4 times the limit of, as x approaches 0, of this, sine of 7x over 7x. And I can actually, because of the properties of limits, I can take the limit of the denominator separately. And so look what I get, sine 4x over 4x. And what we're quickly moving to here is that we have this 7 over 4, and this top one goes to what? 1. This goes to 1. Why? Because it's sine of theta over theta. See that? Sine of theta over theta. And so this is really times 1 over 1, which is 7 over 4. So we might not get that. If you just plug in 0, you're like, well, 0 over 0. That's understandable. Not understandable. So what are we going to do? Well, that's how you do that. Okay, so there's some trickier ones too down here. Okay, so let's do these ones. All right, so again, this one you can plug straight in. You can plug your 0 straight in because continuous function, and guess what? The limit as x approaches 0 of x squared plus the limit as x approaches 0 of cos of x. This is no problem. What happens when you plug 0 in there? Well, it's 0. What happens when 0 gets plugged in here? Cos of x, that's going to be 1. So that equals 1. Okay. Now this one here, again, this is number 27 from your assignment. But this one here is a bit tricky in the sense that we can't use the sine x over x. I don't think, can we? Yeah, actually we can. But it's going to be later. What do you notice about this right here? 1 minus cos squared x. Okay, that actually can be rewritten according to Pythagorean identities, right? So if you recall, sine squared x plus cos squared x equals 1. And so if you manipulate this, 1 minus cos squared x equals, dun-da-da, sine squared x. So watch what we're going to do here. The limit as x approaches 0 of sine squared x over x squared. Now that's pretty close. That's not exactly what we're looking for, but watch what we can do. The limit as x approaches 0, this is like saying sine x times sine x. And this is like saying we have an x times an x in the bottom. So guess what? We have sine x over x times sine x over x. Properties of limits says that you can do this. You can separate them. And here we have 1 times 1 equals 1. Right? Yep. Okay. So let's see. So that's another one there. Good? Good question? I guess there's no questions today. So there's your assignment. Now again, limits of trig, just go ahead and plug x approaches whatever that value is. Those are continuous functions. Plug them in. If you get something over 0, you got to see if you can manipulate. If you get 0 over 0, you got to see if you can use any kind of, Pythagorean identities, or use this limit as x approaches 0 of sine x over x equals 1. Use that. So you have some tricks up your sleeve there to work on that. But go ahead and simply plug them in, and that shouldn't be a big deal for you. Okay, I'll do one more quick question with you here before we end this video. This one I think is one of the more difficult ones. So 1 minus cos x, that's not exactly a Pythagorean identity. It's not a squared, right? But what we can do is we can start to manipulate this by multiplying 1 plus cos x here. You could do that, right? Because we can make that into a difference of squares. So let's see. The limit as x approaches 0. This is going to be, now, up top, we're going to have sine squared x. This is all times 1, right? Cos x. Plus, so this is going to be sine squared x cos squared x. You see that? Now this is going to be 1 minus cos squared x. So this is one of the ways that we can, manipulate an equation, right? Multiplied by the conjugate, top and bottom. You're just multiplying by 1 there. You're not really changing anything. But what this does is this. Now we have this Pythagorean identity. So this is what we're going to do. We're going to factor out a sine squared from the top. See that? Sine squared x. Let's take that out. You're left with cos x plus cos squared x. So we could have factored a cos out too, but we won't need to do that. 1 minus cos squared x is actually sine squared x. So you see where I'm going here? Now I've got this. Those are common factors. And so with those gone now, look at this. I can actually just plug 0 straight in to these guys, right? And so what does this actually become? This is cos of 0 plus cos squared of 0. That's going to be what? Cos of 0 is 1 plus 1 squared. That's going to be 2. All right? So again, limits of trig functions, not that hard. Hope you learned something here today. And again, if you're in my class, this is probably your assignment. You can check that out. And if not, I'll give you the textbook here. So this is what the textbook looks like if you want to do some of those questions, okay? Oops.